Okay. An aeroplane is to fly in a straight line from B to point Q due north of P and back to P again. The aeroplane flies at 250 kilometers an hour relative to the air. There's a wind blowing southwest from 50 kilometers an hour. Calculate the ratios of time taken from P to Q and Q to P. Alright guys, so let's simplify this situation, alright? Plane, really poorly drawn plane, worst plane ever, can go 250. We all cool with that, alright? Let's say the wind is directly behind that at 50. Alright? What, to somebody standing on the ground, what would they see happening above them? They would see a plane going what speed? 300. Okay? First thing you want to do is you want to make sure that you construct your formula properly, alright? Are you using VAP or VPA? Is it the velocity of the air in the plane or the plane in air? VPA makes sense, right? And you're about to show that it makes sense in a second. You're going to prove to yourself that it makes sense. You're going to isolate VP on its own. VP is what the person on the ground sees, and so this is the most common mistake, right? So what does the person on the ground see with my really basic example? It sees 300, doesn't it? And the plane in air, in still air, is 250, and then the velocity of the air is 50. Does that make sense now? So that's that formula on a really basic level, okay? So you're going to use that formula now, and you're going to see what information you can pull together. You should always do the really basic example to start off, because then you can prove that your formula works to yourself, okay? Now, let's have a look at this then. Okay, so what direction does it want to go in at the start anyway? It wants to go north, right? And it has the ability to go north as well. P, Q, plane. Alright? So plane is going to go straight up from P to Q. Happy days, right? So what do we know straight away then? What direction do we know straight away? We know VPA. Oh, sorry. No, not VPA. We know the direction of VP. What do we know the direction of VP? A person on the ground will see that plane going due north. It has the ability to go due north. It will go due north. Person on the ground sees it go straight up north. Okay? Happy days. We know VPA is 250. What do we know about the wind blowing from the southwest? And blowing from is where we're going to make the mistake. What direction is it actually going? Northeast, right? So that's it. And we're in a lovely position right now where we have 4 pieces of information, okay? So the reason why I learned to do it this way is, as you can see on the previous question, there's no other way of getting that done than using the triangle law, so you have to use the triangle law anyway. So I learned how to do most things through the triangle law, okay? So here's what we're going to do. So VP is the one on its own, isn't it? So VP goes due north. There's VP. What happens next then? So it shows VP, which is on its own on the left. So what do I do next to make this triangle work? Pick one of them on the right. Which one do you have more information about? VA. Alright? And VA goes 50 at northeast. And then what about VPA? It's going some sort of northwesterly direction. Does that northwesterly direction make sense? If you have a wind blowing from the northeast, you have to battle the eastern component of it, don't you? So what does that mean? You have to fly west. So that diagram should make complete sense to you. That VPA, you're aiming your plane in a northwesterly direction, And now you have enough information to do everything there. So what's the first thing we know? If that's 45, what does that mean? That's 45. We know that VPA is what? 250. And what else do we know? That's 50. And now I have access to a sine rule. That should tell me everything I need to know about the triangle. So if somebody can work ahead of me here, on using your calculator, and just figure out what the angle is, that will speed us along nicely. Yeah. X should be really small, is it? So when you sine inverse it, make sure it's in degrees. What you get? 8.13. Exactly, it's a really small angle. You lose that 8.13. So we know that X is 8.13. What does that make the other angle then? 180 take away 45 take away 8.13. Group 126.87. I'm going to calculate what phi p is now. So let's calculate phi p using another sine rule. So it's going to be phi p over sine 126.87 equals, pick any other two you want. I'll probably just go for the 250 and the 45 again. So will somebody get me a value for phi p? Over sine 45. Have we got a phi p yet? 282.84. Is it meters per second or kilometers per hour? Kilometers per hour. Alright. Happy days. Now, all this gone. We're on the return journey now. Okay. Now we're on the return journey. Oop, sorry. So this p value, the direction we went in last time is gone. Our plane is here. We want to go directly south. First of all, prediction. Will it be faster or slower than the way up? Slower. Why is it slower? Yeah, it had the north boost on the first one. Now it's fighting the north part. It's still going to go west, isn't it? Why does it have to go west? Exactly. So look, we already know what's going to happen here. This component here is going to be aiming in this direction. Okay, and it's going to get put straight. So we go back to Magda again, and this time what's the deal? It's going south. That's the only difference. Okay? So we have phi p that's going directly south, but what's the difference this time? Alright, so sorry, I joined all that together, never mind. I'll say wrong question. So phi p is going directly south. Like so. Okay, phi p. Happy days. And what are we going to do next? We're going to aim in which direction to fight that? We're going to aim this direction. Or, if you're being honest, what direction is the air going again? Northeast. Yeah, northeast. That's phi a. So what does that mean links them together? What links the two lines together then? Phi p. Phi p is on its own, and it's phi pa plus phi a. So what does that mean this has to be? Phi pa. What direction is phi pa going in? Some sort of southwest direction, okay? Now, what can we say about this angle this time? That's 45 degrees. What's the whole thing? 135 degrees, okay? That makes the angle opposite phi p smaller, because phi p is not going to be the longest line in this triangle, because you're fighting the wind, you're not getting the boost from the winds, okay? Now, phi a is what, guys? 50. Okay. Phi pa 250. Call this angle x. So what can we say about sine x? You be quick on this to calculate sine x for me. Sine x over 50 equals what? Sine 135 divided by, anybody else? 250. And what do we get here? Really? Loves that. Whoever makes the examcraft one seems to love that angle. 8.13. Do we have to, is there any point doing 180 minus that angle? Why not? There's only one possible direction, is there? Because there's already a 135 degree angle there. You can't have another obtuse angle. Doesn't make sense. Alright, so now you know that this angle here is 8.13. What can you say about the next thing then, lads? That's 8.13. You now need to find out what phi p is. So what's phi p again? So we need to find the phi p for the way back. We're expecting it to be below 282.84. So we call this b, is it? Okay, so what do we get here? Oh, sorry, we know angle b, don't we? What is angle b? 180 minus 135 minus 8.13. Is it 36.87? Alright, it's 36.87. So, phi p divided by sine 36.87 equals, was it phi 250 over sine, what's the sine? 8.13. So what do we get here?
It's 250, not sine 135.
Yes, it is. Thank you, Killian. And what do we get here, guys?
181.41.
100 and?
181.41.
Twice the speed, isn't it? Or no, it's not twice the speed. I thought it was for a second. Alright. It wants the ratios of time, doesn't it? Calculate the ratio of times taken from B to Q and Q to P.
It's not 212.
Can somebody have another go at that? 250 sine 36.87 divided by sine 135. So what is it? 212?
212.13.
Alright. Now, to calculate the ratios, I'd once again use the simplification technique, alright? So imagine this, you have a distance of D. One of them's going 100, the other one's going 50. Or even, I'm even going to make this a lot easier. You have a distance of 200. One of them's going 100, the other one's going 50. What's the ratio there? One of them takes 2 hours, the other one takes 4 hours. Is that correct? So the ratio of T1 is to T2 is basically, 2 hours is to 4 hours, which is a ratio of 1 is to 2. It's essentially the same ratio as velocity 2 is to velocity 1. What's velocity 2 is to velocity 1? It would be 50 is to 100. So we could just go direct with the same thing here. We can just say it's an answer of, we can just say it's phi 2 is to V1, which is 212.13 and 282.84. Now, I'm sure they were looking for some sort of fraction here that obviously was lost in translation with the rounding off. Have any of you already done this question out of interest? Alright, so I'm just going to divide the two of them together and see if it mimics any fraction. Oh! It wasn't lost in translation, it's a ratio of 3:4. Convenient, happy days. That worked out nicely. I'll take that.
That's it.
Yeah.
I'm a bit confused of where that 8.1 degrees is on the angle.
Which one?
The 8.1 degrees.
Here?
Yeah.
Okay, so for the 8.13 degrees, what we used was an angle we didn't know it at the time. So we called it sine x, okay? And we used the sine rule where this 8.13 is opposite to 50, and the 135 is opposite to 250, and that's this sine rule here. That's where we calculated the 8.13 from. Is that alright?
How were the planes angled?
Okay, so the 8.13, if I just strip all this back down again. So the 8.13 is not the direction of the plane. See, we weren't asked for the direction of the plane, we were just asked for the ratios of the times. Right, so I didn't need to get that, but if you're looking for the direction of the plane, I can do that now, right? So what it is VPA is where you actually direct your plane. Okay? This one here, VP is where your plane actually goes. Your plane actually goes dead south, but it's not where you aimed, because you have to aim southwest to fight the breeze. Okay? So technically this angle here is the angle you aimed your plane in. Okay? And it actually would be it'd be south 8.13 degrees west. It's that angle there. It's the one where you actually aim your plane. Is that alright? Right, grand. Now, I'll just save that.